Hey everyone! Today we are going to explore the Nucleo Board STM32f0 series. We are gonna check out how to program with HAL and see how they are different with Arduino. Moreover, we will also show you different ways to connect digital devices and give you a quick demo where you can control an LED with a push button. Let's just dive right in. HAL or Hardware Abstraction Layer is a bunch of libraries made by ST Microelectronics for STM32 microcontrollers. It simplifies the programming of complex hardware functions. The HAL is quite different from Arduino programming, which is made for beginners and hides a lot of the complicated stuff. Let's compare all of them. STM32 has a lot of types of digital I/O. We will illustrate clearly each type of them in the simulation. On the input floating, the pin is in a high impedance state and doesn't have a defined voltage level unless driven externally. On the input pull-up, an internal pull-up resistor is connected to the power source. In the pull-down, an internal pull-down resistor is connected to the power ground. Output open drain. The pin can either be in a high impedance state or connected to the ground. Usually, it uses the N-channel MOSFET. Lastly, output push-pull. The pin can drive both high and low states actively. Usually, it uses the P-channel MOSFET. This is the summary of input and output digital. Today, we are going to implement the input floating and output push-pull. This is the schematic of the STM32 Nucleo Board. We attach the file to the link description. The name code of the schematic is MB1136. First, we need to open the third page. After that, take a look at the GPIO PC13. If you rotate the pin, you will find the B1 or a blue push button. In the Nucleo board, the input push button has an external pull-up resistor. That's why we use the input floating. Then, find the pin PA5 or D13. Lastly, open the last page or fifth and take a look at LED2. It connects to the input D13 or PA with an external resistor. Let's jump into the STM32Cube IDE. Our project name is Digital I/O and set all default configuration. First, we need to initialize the GPIO pins. We only use two types of GPIO ports. This code has private function prototypes. It means a declaration specifying the function's return type, name, and the number, and types of its parameters. On the main function, the code generation builds several initializations including GPIO. If we deep dive into GPIO init function, these are the configuration of our GPIO. Now, we set GPIO PC13 as an input floating and the GPIO PA5 as an output push-pull. Next, jump into a while loop. Then, create a reading button state in the while loop using GPIO PC13. If the button is pressed, the LED will turn on. In the opposite reading state, the LED will turn off. Now, let's flash the code to our STM32 board. When you push the button, the LED turns on. It's a straightforward way to show off how well HAL can handle digital input and output.